We've all started out using AI with these simple one-line questions, right? But to get those really great, consistent results, well, you got to move beyond just asking questions and start engineering answers. So today, we're going to crack open the professional's toolkit. We're talking about some seriously powerful techniques like prompt chaining, self-consistency, and even getting AI to judge itself. I mean, have you ever asked an AI for something, like marketing copy, and gotten pure gold one day, and then the very next day you ask for something similar, and it gives you back just total garbage, like it was written by a bored teenager? It's so frustrating, right? Well, here's the thing. That inconsistency, it's not just some random flaw you have to put up with. It's actually an engineering problem. And the good news is, it's a problem we can solve. Okay, so this really gets to the heart of it. The difference between a simple prompt and an engineered one. Look, a simple request like write a story, that's basically a lottery ticket. I mean, you might get lucky, but you probably won't. But an engineering prompt, that's a blueprint. It's a whole process, a structured set of instructions that actually guides the AI to where you want it to go, every single time. So the big question is, how do we build that blueprint? How do we get the AI to think more like, a real creative partner instead of just a glorified vending machine where you put in a coin and hope for the best? Well, that's what this first part is all about. We're going to dive into what I call the reasoning toolkit. All right, first tool in the box, prompt chaining. The easiest way to think about this is like an assembly line, but for thoughts. Instead of just shouting, hey, build me a car, and hoping it turns out okay, you're breaking it down. You tell the AI, okay, first build the chassis, then next install the engine, and then now paint the body. You get quality control at every single step. So how do you actually do it? It's really pretty simple. Step one, you take your big, hairy problem and you just chop it up into smaller, bite-sized pieces. Step two, you write a separate, specific prompt for each one of those little pieces. And then, the magic part, you chain them all together. The output from prompt 1 becomes the input for prompt 2, and so on. It's kind of like building with Legos, just one logical block at a time. Okay, next step in our toolkit is something called self-consistency. And this one, it sounds almost too simple, but trust me, it's incredibly powerful. Just imagine you've got a whole committee of AI experts in a room. Instead of asking just one of them for an answer, you ask the entire committee the exact same question. And then, you just take the majority vote. It's that straightforward. And yeah, the process is exactly as simple as it sounds. You just run the exact same prompt, say 5 or 10 times, you'll get a handful of different answers, you collect them all, and then you pick the answer that shows up the most often. It's a fantastic way to kind of average out all the weird randomness and land on a result that's way, way more reliable. All right, now we're getting into the really advanced stuff, tree of thought, or TOT. So imagine the AI is working on a complex problem, and it hits a crossroads. Now, with prompt chaining, it would just pick one path and stick with it. But with tree of thought, it explores multiple paths forward, all at the same time. It's like it's looking down each path, evaluating it, and then deciding which one is the most promising. Think of it like a chess grandmaster, considering all the possible moves and their consequences, thinking several steps ahead to find the absolute best strategy. Now, I know this diagram looks a little intimidating, but the core idea is actually pretty simple. You start with your main idea at the top. Then, at each step, the AI generates a few different potential paths forward, like branches on a tree. It then evaluates each of those branches, prunes away the ones that aren't working, and continues building on the strongest ones. It's this constant cycle: generate, evaluate, refine, over and over. Okay, so we've given the AI all these cool new ways to think. That's great, but how do we actually know if its answers are any good? How can we prove it's getting smarter and not just, more creative at being wrong? We need to be able to measure the quality. And that brings us to the second half of our toolkit, the validation toolkit. Right? I mean, you've spent all this time crafting the perfect multi-step tree of thought prompt, and the results, they feel better, they seem better. But how do you prove it? How do you move beyond just a gut feeling and get to the cold, hard data that shows, yep, this new prompt is quantifiably better than the old one? That's the million-dollar question we're tackling now. And the answer, surprisingly enough, starts with something you probably haven't thought about since high school: a rubric. Yeah, seriously. Just like the one your English teacher used to grade your essays, with criteria for clarity, grammar, and originality, we can do the exact same thing for our AI's output.
It's all about sitting down and clearly defining what good actually means to us.
So, how do you build one? Well, first, you figure out your main goal. What are you trying to achieve? Then, you break that goal down into clear criteria, things like relevance, clarity, conciseness, whatever matters for your task. Then, you whip up a simple scoring scale, maybe 1 to 5. Write a quick description for each score level, and boom, you're ready. The key, though, is applying that rubric consistently to every single output you evaluate. Okay, but grading one response at a time, that's like test driving a car just around the block. Sure, it's helpful, but it doesn't tell you the whole story. That's where batch testing comes in. Batch testing is like taking that same car on a massive cross-country road trip. You're not just checking it under ideal conditions, you're properly stress testing it, throwing every weird, challenging scenario you can think of at it to see how it holds up at scale. And the best part? You don't have to do all this manually. I mean, can you imagine? No, there are tools for this. Things like Prompt Flow let you just upload a big data file with all your test inputs, run your prompt against the whole batch at once, and then you get all the aggregated results back. It is by far the fastest way to get real, hard data on how well your prompt is actually performing. All right, so we've got techniques to make the AI think harder, and we've got ways to measure if it's working. But what if we could automate the measuring part too? What if we could take the human grader out of the equation completely and have an AI do the judging for us? Yeah, that's where we're going next. This whole idea is called AI as a judge, and it's pretty much exactly what it sounds like. You use one large language model to evaluate the outputs of another one based on that exact same rubric we just talked about. Why? Well, it's faster, it's way cheaper than paying a human, and you can scale it up to evaluate thousands of responses almost instantly. Now, I know what you're probably thinking. Wait a minute, can we really trust an AI to be a good judge? And that's a fair question. But this quote really hits on why it works. See, these models are trained on, well, basically the internet, a massive aggregation of human opinion and knowledge. So when you ask it to make a judgment, it's actually pretty darn good at representing what the masses would think. And here's where it gets really cool. An AI judge doesn't just spit out a number, it gives you the why. It'll provide a detailed explanation of its reasoning, pointing out the specific strengths and weaknesses of the response. It even gives you concrete suggestions for improvement. It's basically like having a personal, on-demand tutor for your prompt engineering. You can also use this to create a sort of AI showdown. Here you've got a judge model, Panda LM, looking at responses from 2 different models, Bloom and Llama. It compares them side by side and then declares a winner. It's basically an AI rap battle, and the judge gives you a play-by-play of who won each round and why. It's pretty amazing. So let's put this all together. We have our reasoning toolkit to generate better outputs. We have our validation toolkit to measure how good they are. What happens when you connect the two? You get a feedback loop. You create a system that is constantly learning, constantly improving, basically getting smarter all by itself. And this diagram really shows the whole beautiful cycle. You start with a prompt, you test it. An evaluation model, our AI judge, scores the output. And then that score gets fed into another model, an optimization model, whose only job is to create an even better prompt based on that feedback. It's a fully automated, self-improving system. And really, that's the key takeaway here. This is about a fundamental shift in how we think about this. It's not about being a prompt artist anymore, hoping for a happy accident or a flash of brilliance. It's about becoming a prompt engineer. It's about building a systematic, repeatable process that delivers reliable, high-quality results time and time again. Which, of course, leads to a pretty huge question. As we engineer these AI systems that can reason, evaluate, and even correct themselves, what does our role become in all of this? Are we becoming the architects of a totally new kind of creative process? Or are we just designing the tools that will eventually, well, replace us? Definitely something to chew on.